the topic. First of all, I am G.Sivakaumar, Assistant Professor, Computer Science Department in PSN College of Engineering and Technology. Now we are going to see the overall concept about computer graphics and multimedia. First, we discuss or we see the topics related to the computer graphics, and then we see the multimedia concept. So first, the first slide is the overview of computer graphics. So what is computer graphics, how the graphics is related to the computer, and what are the concepts and what are the factors, then computer graphics advantages, disadvantages, then computer graphics applications, what are the inputs that we are given to CG and what are the output we get from the CG. So these are the topic we covered under the overview of computer graphics. Okay, first, the foremost one is what is the correct definition and what are the importance of computer graphics. So the term computer graphics, shortly it is known as CG. So describe the use of computers to create and manipulate images. So normally we can know the images. Okay, the images is nothing but the combinations of rows and columns. That rows and column is considered as a pixel. So if the image is to create or manipulate in the form of display devices, that is the computer, the use of computer, that is known as computer graphics. So here the graphics is nothing but images that we can display with the help of computer, that is known as computer graphics. So normally graphics can be two parts, that is 2 or 3 dimensional, that is 2 dimensional or 3 dimensional. So here already we see the definition. CG is a creation and manipulation of images or pictures with the help of computers. So basically there are two types of computer graphics. The one is passive computer graphics and another one is active computer graphics. Okay, so this passive and active, how the name passive and active is come means related to the CG, that is non-interactive is passive and interactive means active. So what is non-interactive? So non-interactive means that is not, that is negative. So here the interactive by the user. If the user not interact to the computer graphics, that we can't change anything, that is known as passive computer graphics. So that is non-interactive. Just the user view the picture or image only, not to change or change the coordinates of the images. So other side, active computer graphics means interactive computer graphics. Here in the interactive computer graphics, the user can easily interact with the images or pictures. That is the basic difference between non-interactive and interactive CG. So here we see the definition of CG. So the images can be created or manipulated with the help of computer is known as CG, and there are two types of CG. The one is passive and another one is active. The passive is considered as a non-interactive CG and the active computer graphics is considered as a interactive CG. Next, the PPT continue about the CG. So here when the CG takes place with the help of computer, the main element or the main component is the images or pictures. Okay, so we can see the image or picture with the help of computer under in the computer graphics. So with the help of CG, the picture can be represented in 2-dimensional and a 3-dimensional space. So 2-dimensional space means that is a 2 coordinate x, y, and the 3-dimensional space is that is a 3 coordinate x, y, z. So here in the word we have the various applications in CG. So in the various applications we can show the various parts of the pictures based on the size and orientation. Okay, so by changing the size and orientation, such a type of transformations or the picture can be made to grow, shrink or rotate. So using the help of the transformation, the picture can be made to grow, increase or shrink, or some transformation can be happens, or some rotate with with angle. So these are the content that we are achieved through computer graphics. So then next one is display. So what are the factors that we are considered for the transformation? That after transformation, the pictures can be displayed in the CG screen. So with the help of CG, a technique called clipping. So what is clipping? So in the CG projection plane, what are the images that we are going to see by the user? That we are the images that are not seen by the user. So that part only we can taken from the computer graphics. Okay, so in this concept there is one factor that is called the clipping window. So what are the line or anything point or images or pictures that we are seeing inside in the computer clipping window, that part only visible. So outside the clipping window, that part cannot be visible by the user. So just what are the images that we see in the clipping window that we can visible or see. Another part that we can discard or we can remove the images from the clipping window. Next, so the computer graphics is nowadays used in the field of science and engineering, medicines, entertainment, then advertising concept, the graphic arts, then fine arts, business, education. So the computer graphics is applicable in the various fields. Then particularly in the electronic industry, there is more dependent on the technology provided by the CG, such as engineers can draw their circuit in much shorter time. So using the computer graphics, we can easily make the circuit with the help of the different tools and different applications. Okay, then architect. So consider that the civil engineer, so the architect can be have the alternate solution to design problems. Then for the medical field, molecular biologist can display pictures of molecules and can study on the structure about the molecular particles and the molecular items. And the town planners, transportation engineers use the computer generated maps with the display data useful to them in their planning work. So these are some fields that the CG is most applicable. Then interactive computer graphics. So already we see there are the two types of CG. The one is passive and another one is active. So here the active CG is considered as a interactive. So here in the interactive computer graphics ICG, it provides two-way communication between the computer and the user. Here the user and the computer can interact with them. That is, the user can easily change or modify or something, that transformation can be implemented in the CG. What are the objects that are displayed in the CG? So the various applications. What are the various applications of ICG is, first, using the ICG system, using the integrated computer graphics, the integrated electronic circuits, which are very complex, can be drawn in much shorter time. So without that interactive CG, the integrated electronic circuits are very complex. But with the help of CG, we can easily draw. The next, it is very useful in the training of the pilots, that they spend much of their training on the ground at the controls of a flight simulator, not in the real aircraft. So what are the non-possible that we can made in the real aircraft, we can easily, with the help of CG, we can easily training the pilots. Then what are the other means? There are many tasks that can be made easier and less expensive by the use of ICG. The effectiveness of the ICG is the speed with which the user can observe the displayed information. So using that interactive computer graphics, the user can be easily display the information. Next, so here we consider the diagram. The interactive graphics display consists of three major components. What are they? First one is the frame buffer, the second one is TV monitor, and the third one is display controller. So here from the diagram, left, then middle, and the last to the left with the consist of zeros and ones. That is binary digit is as a frame buffer, and square box is considered as a display adapter or display controller, and the last one is video monitor or TV monitor that the user can see the image. So in the frame buffer there are zeros and ones, combination of zeros and ones. This zeros and ones can be considered as a scan line data. Here each and every bit can be scanned and the data can be captured, and what are the data that are captured, that data can be come into the display adapter or display controller. So once the data is in the display adapter or display controller, that data we can view in the video monitor or TV monitor. So this is the interactive graphics concept using the help of three major components: frame buffer, TV monitor and display controller. Then next, what is frame buffer? Let us see one by one. So what is frame buffer? So here in the frame buffer, the images that are to be displayed or stored in the frame buffer. First, in the frame buffer we can store the images in the form of matrix of intensity values. The intensity value is nothing but the zeros and ones. Then the frame buffer contains the image stored in the binary form as a matrix of zeros and ones which represent the pixel. So here the 0 indicates the darkness and 1 indicates the image. Okay, the frame buffer holds the set of intensity values. So in the previous slide we can see the set of intensity values, that is the combination of zeros and ones. Inside the frame buffer there is a combination of zeros and ones. This combination of zeros and ones are considered as a screen points. Then next, the intensity values stored in the frame buffer are retrieved and painted on a screen one row at a time. So here we can see that is scan line data. Here the data line can be scanned by one. So it is one row at a time. This row is called as a scan line. Then next one is this display controller. That is a display adapter or display controller. Here in the display controller, what are the scan line that are considered in the scan line data that passes to the content to the display controller. Here the display controller passes the content of frame buffer to the TV monitor. So what is the main role here in the display controller? Means the combination of zeros and ones, that is the scan line scanned row at a time, just one row at a time. That row can passes to the TV monitor with the help of display controller. Here the display controller reads successive bytes of data. Successive bytes means the next data. Okay, followed by the other. So successive byte of data from the frame buffer and then convert zeros and ones into the corresponding video signal. So what is the corresponding video signal? Here when the scanline data scans the 0, it is .1, and when the scanline data scanned 1, it is considered as a image, that is brightness. Okay, into the corresponding video signal. This signal are fed into the TV monitor. So using the display controller, it can read the successive byte of data from the frame buffer and convert zeros and ones into the corresponding video signal. That signal that are fed into the TV monitor. So the last one is TV monitor or display monitor. So here in the video monitor or TV monitor, it produces the black and white pattern on the screen. So 0 considered as a darkness and 1 considered as a white pattern. So in the TV monitor we can see the combination of zeros and ones in the frame buffer, that the frame buffer then go to the display controller, and again the display controller view the signal that are present in the TV monitor, black and white pattern. Okay, here the frame buffer content ought to be modified in order to represent the new pattern of the pixel, or if some changes are made on the displayed picture. So this is the interactive computer graphics. Then graphics area. So what are the major areas that the computer graphics are considered? The first and the foremost one is modeling. So the modeling, what is the modeling? The modeling deals with the mathematical specification of shape. and appearance property in a way that can stored on the computer. So what are the shapes or what are the objects? Each and every object, each and every shape has some properties. That properties are specification in the form of mathematical concept. For example, a coffee mug might be described as a set of ordered 3D points along with some interpolation rule to connect the points and a reflection model that describes how light interacts with the mug. So this is the modeling concept. The next one is rendering. So the term rendering is very basic term and very an important term that when we study about the computer graphics. So here the rendering is a term inherited from art and deal with the creation of shaded images from 3D computer models. So this is the concept of rendering. So rendering is nothing but the captured image from art. This is rendering. Then animation. It is a familiar word. We all know about the animation concept. So animation is a technique to create an illusion of motion through sequence of images. So in the real-time world, what are the complex data in the real-time world? That complex data or complex images, complex pictures can be easily we can create in the illusion of sequence of images in animation concept. So here the animation uses modeling and rendering but adds the key issue of movement over time, so which is not usually deal with in basic modeling and rendering. Okay, the next one is user interaction. So user interaction, that is interactive computer graphics. It is already we know about the deals with the interface between input devices such as mic and the tablet, the applications, then feedback to the user in the imaginary and the other sensory feedback. Then virtual reality. So virtual reality is it attempt to immerse the user into a 3D virtual world. It is not a real world, it is a 3D virtual world. This typically requires at least stereo graphics and response to head motion. For true virtual reality, sound and force feedback should be provided as well. So using the virtual reality concept, we can easily feedback the sound and force that we provide as well. Then visualization. So visualization is nothing but to display the device, so to display the object or to display the picture or to display the images. So here the visualization attempt to give user insight into complex information via visual display. Then image processing. So image processing is one of the important technique that we are used in the CG. It deals with the manipulation of 2D images and is used in both the field of graphics and vision. So next 3D scanning. So 3D scanning nowadays it is a very important one in the medical field. In the 3D scanning uses a range finding technology to create measured 3D models. Such models are useful for creating rich visual imagery, and the processing of such models often requires graphics algorithm. So whenever we use in the 3D scanning, some graphics algorithms are used in the concept. Then computational photography. So here in the computational photography, it is the use of CG and the computer vision and the image processing methods to enable new ways of photographically capturing object, scenes and environment. So using that CG, when we are take the real-time photograph, so after we can make some CG concept in the object or scene or environment, we can easily make the new way techniques. Then applications. So almost major field that the CG is used, but when we can take part in the consumers of computer graphics technology, we can include some industry oriented. The first one is video games. So video games usually using sophisticated 3D models and the rendering algorithms. The first one is video games and the second one is cartoon. So we can see so many cartoon channels that children can see the cartoon images in the various channels. So in the cartoons are often rendered directly from 3D models. Many traditional 2D cartoons use backgrounds rendered from 3D models, which allows a continuously moving viewpoint without huge amount of artist time. Then visual effect. So here the visual effect is mostly used in the film related CGs. Here in the visual effect is almost all types of computer graphics technology. So every modern film uses a digital computation to superimpose backgrounds with separately filmed foregrounds. Many films also use 3D modeling and animations to create synthetic environment, object and even characters that most viewers will never suspect are not real. So next to the animated films. So using the same CG technique used for visual effect, but without necessarily aiming for images that look real. Then CAD, in the education field, mainly in the mechanical environment, we can use the CAD and CAM, computer aided design and computer aided manufacturing. So these fields are use computer technology to design parts and product on the computer, and then using this virtual design we can easily guide the manufacturing process. For example, many mechanical parts are designed in a 3D computer modeling package and then automatically produced on the computer controlled milling device. Next one, simulations. So here in the simulation part, it is very useful to capture the accurate video gaming. For example, a flight simulator uses some specificated 3D graphics to simulate the experience of flying an airplane. So in airplane, in the real world, we go to the airport and we take the ticket and then we boarding, and then some procedures are there in the real world. But in the simulation part, using the 3D graphics, we can easily to have the experience of flying an airplane. So such simulations can be extremely useful for initial training in safety critical domains, such as when the pilot driving the aeroplane, and for scenario training for experienced user, such as a specific fire or fighting situation that are too costly or dangerous to create physically. Then medical image. So in medical images, then MRI, CT, to scan the data to the patient. For example, a CT scan, a computed tomography CT data set is composed of a large 3D rectangular array of density values. In computer graphics, is used to create shaded images that help doctors extract the most salient information from such data. So in medical field, CG is very applicable. Then information visualization. So here in the information visualization creates an image of data that do not necessarily have a natural visual depiction. For example, the temporal trend of the price of 10 different stocks does not have an obvious visual depiction, but clever graphing technique can help humans see the patterns in such data. So some data, when we consider that data, we can normally not able to see. So in case of that data, using that CG, we can easily see the patterns that are inside in the data. Then presentation graphics. So here in applications like summarizing of data of financial, statistical, mathematical, scientific and economic research reports. So these are the various applications that graphics can be presented by the financial or statistical or mathematical, scientific and economic. The presentation graphics are used. It increases the understanding visual tools like bar chart, line graph, pie chart and other display. So from the above created report, so using the bar chart, line graph, we can easily get the display of the output. Then graphics pipeline. So what means pipeline? So pipeline is nothing but the series of patterns. Okay, so here in CG, the graphics pipeline refers to a series of interconnected stages. So each and every stage, that is the previous one and the last one, middle one, that all the stages are interconnected through some data and commands related to a scene during the rendering process. So when the pipeline concept takes place, it have a mathematical description of an object to its representation on the device. The figure 2. So here the figure 2, a 3D graphic pipeline. Okay, here in the figure 2 shown the illustration of a 3D graphic pipeline. So in the real world object are represented in world coordinate system, that is all over the world what are the basic coordinate system that we are used, it is then projected onto a view plane. So the projection is done from the viewpoint of the position of a camera or a human eye. So there is an associated camera coordinate system whose z-axis specifies the view direction when viewed from the viewpoint. So in 3D, the z-axis is considered as a view direction. The infinite volume swept by the rays emerging from the viewpoint and passing through the window is called as view volume or view pyramid. So clipping planes that are near and far are used to limit the output of the object. So here we can see a 3D graphic pipeline. Here there are the 3 coordinate system, that is x, y and z. So it is a 3D model. So it is a camera coordinate system, and already we see that in the previous slide the eject position is the viewpoint, that is the location of camera or a human eye. So when the human eye or camera to view the location of the viewpoint considered based on the z direction, then the next one is near clipping plane, that is front or either plane, and the next one is view reference point, that is in the view plane. So inside the view plane there is one clipping window. So in the clipping window we can see the images. So the first, when the human eye captured the object from the viewpoint, the first one is the near front either plane, and the next one is the view plane. Inside the view plane there is a window. So here in the window there is one point that is known as view reference point. Here the view plane origin. View plane origin is considered what are the origins or what are the axes that are represented in the middle of the object. That middle of the object we can consider as a view plane origin, and then here it is a front and here it is the far. So far clipping plane is the foremost from the camera or eye. So here view volume or view pyramid. So this part is considered as a view volume or view pyramid. So from a 3D graphic pipeline, it is the one stage after the another. There is a series of stages from the viewpoint, that is the location of camera or eye. Okay, so here the mapping of an object to a graphic device requires the transformation of view plane coordinates to physical device coordinates. So there are 2 steps involved in this process. So when the object can be mapped to a graphic device, that graphic device requires the transformation of view plane coordinate to the physical device coordinate. So what is the view plane coordinate? The view plane coordinate is the screen coordinate. So screen coordinate is under the image space method, and the physical device coordinate is considered as an object space method. So there are 2 steps involved in the process. The first one is the window to a viewport transformation. The first one is the window to a viewport transformation. The viewport is basically a sub-rectangle of a fixed rectangle known as logic screen. The second one is the transformation of logic screen coordinates to physical device coordinate. So first the viewport have a subrectangle of a fixed rectangle. That fixed rectangle is known as a logical screen. So once we can find out the logical screen, after that the second process is the transformation of logical screen coordinate to the physical device coordinate. That is a 2D becomes x comma y and 3D becomes x comma y comma z. So the figure 3 and figure B. What is the figure 3? A sequence of transformation in weaving pipeline. In the weaving pipeline. So first the representation of 3D world object. So what are the object that we are consider? That object we can take by the 3D XYZ format. Then once we can take the object in 3D, next it move on to the transform into camera coordinates. Okay, then after that camera coordinates, then the clipping against view volume. So the clipping part we can take. Once the clipping against the view volume step is finalized, then we can move on to the project to the view plane. Here in the project to the view plane, we can see the object inside the clipping window, and after see the object inside the clipping window, then next it is transformed into the viewport. So here in the viewport, the final step is transformed to the physical device coordinate. So first starting one is we can take the 3D object, and these are all the intermediate steps that can transfer into camera coordinate and the clipping window, and inside the clipping part we can view in the view plane, and after that the view plane can be considered transferred to the viewport, and at last the viewport is transferred to the physical device coordinate. So it is a sequence of transformation from the starting to ending. And the next one is 2D coordinate system to physical device coordinate transformation. So here in the above figure we can take the 3D world object. So here we can take the representation of 2D world object. So then after taking the 2D world object, then it can go to the clip against the window, that is the clipping window, and once the clipping window, when we can capture the images, then it can move to the transport to viewport. At last it transfer to the physical device coordinates. So in the above we can take the 3D object, in the below diagram we can take the 2D object. Next, what are the display technologies used in the CG? First, the foremost and the very important display, very important display technology is cathode ray tube. So the most common graphics output device is the video monitor, which is based on the standard CRT, shortly known as CRT, that is cathode ray tube design. So here the figure 4 illustrates the basic operations of a CRT. So this is the schematic diagram of the CRT. So from the left side we have a connector pins, and the connector pins are connected in the base, and after the base it has the electron gun, and electronic gun, and the next is focusing system, and there are two deflection plates. The one is horizontal deflection plate, the another one is vertical deflection plate, and at last there is a screen which is coated by the phosphor, and in the phosphor coated screen the electron gun the beam, that is the electron beam. The electron beam is spotted in the phosphor coated screen. So in the previous figure we can see the various spots that are in the cathode ray tube, that is connector pins, base, electron gun, focusing system, deflection plates, horizontal and vertical, and a phosphor coated screen, and inside this phosphor coated screen from the electron gun to the electronic beam. So let us see one by one. First, the electron gun. What is electron gun? So electron gun is the primary component of a CRT. Okay, how the CPU is the main in the computer system, and how the heart is main in the human body, like that the electron gun is the primary component of a CRT. So when the heat is applied on to the electron gun by directing a current, a beam of electrons. So here when the heat is applied through the connector pins using the base, then this electron gun directing a current, a beam of electrons, that is a beam of electrons can be emitted by the electron gun passes through the focusing and deflection system. So once the electron gun is gunned, it can move to the focusing system. That is, the gun is inside the focusing system and cross the two deflection plates, that is horizontal deflection and vertical deflection system, that direct the beam towards the specified position on the phosphor coated screen. Next one is the focusing system. So here the focusing system, the CRT is needed to force the electron beam to converge into a small spot that will strike the phosphor. So using the focusing system, it can directly focus to the phosphor coated screen. And there are two pair of deflection plates. The one is horizontal and the another one is vertical. So one pair of plate is mounted horizontally to control the vertical deflection, and other pair is mounted vertically to control the horizontal deflection. So using the deflection plate, horizontal and vertical, the electron beam not scattered where it is found. The next one is phosphor. The phosphor then emits a small spot of light at each position contacted by the electron beam. So here, why we are using the phosphor? Because the light emitted by the phosphor fades very rapidly. Some method is needed for maintaining the screen picture. So when the electron gun or electron beam directly attack to the phosphor screen, it will display the facts of electrons and maintain the picture quality easy. So one way to keep the phosphor glowing is to redraw the picture repeatedly by quickly directing the electron beam back over the same point. This type of display is called the reference CRT. So normally the CRT monitors, there are two techniques, rasters can display and randoms can display. So these are the two display type that the CRT monitor have. So what is rasters can display? So here rasters can display. So we can see it is the CRT monitor. So from the CRT inside the electron gun spotted the electron beam to the resistor's phosphorus coating monitor. Okay, so here in the raster scan display, it is a scan line method, that is the line by line method, and each and every electron gun can be spotted in a small point, So consider the right side. So already we see that there are two plates that are in the CRT monitor, vertical and horizontal deflection plate. So using the horizontal retrace, we can have the dotted points, and using the vertical retrace, we can have a continually a line. Okay, so this is called a scan line method. So this is called the scan line method. So here, how the rasters can display the object using the CRT monitor in the spotted light, and then the right side have a horizontal and vertical retrace using the scan line method. So raster scan system, this is a small architecture of the simple raster system. The input output devices, and it will go to the system bus, and in system bus there are the three categories. One is central processing unit, and another one is system memory, and another one is a video controller. At last the monitor can display the object. So here, so this is also the architecture of the raster system. So rasters can display processor. How the raster display processor can be constructed? So here it shows the one way to set up the organization of the raster system containing a separate display processor, sometimes referred to as a graphic controller or a display processor. So already we see the architecture, that is considered as input output devices, system bus, CPU, display processor, and system memory. So here in the display processor, there is a display processor memory, and then frame buffer, video controller, and monitor. So this frame buffer, video controller, that is a display controller, and monitor we can already see in the previous PPT slide. So this is a random scan. So raster scan and random scan. So first we saw about the raster scan. Now we see about the random scan display. Okay, or vector scan display or calligraphic display. So this is the simple one. So in previous when we saw about the raster scan display, the electron gun spotted the electron beam in the spotted dot range. But here in the random scan display, the electron gun can spot the electron beam in the continuous manner. That is the pipeline concept. That is it is a line. Okay, it is a line. So here the architecture of simple random scan system, that is also have input output devices, system bus and the CPU, system memory, display processor and the monitor. Then what are the hard copy devices and what are the input devices for CG? So printers and plotters, hard copies of printers and plotters. And what are the input devices? That are keyboard, mouse, trackball and space ball, joystick, data glove, digitals, touch screen, light pen, voice system, image scanners. These are all considered as input devices. Then next one is once we know the overall view of CG, then what is CG, then what are the two major types of CG, and what are the display techniques in CG, and what are the various fields that CG can be used, and what are the two different displays, that is a raster scan display and a random scan display. Then after that we see the topic about 2D transformation. So in the 2D transformation we can see the value coordinate system, then what are the transformation techniques, that is translation, rotation, scaling, and how the viewport can be transformed, and then the last all the 2D transformation comes under in the one system. So first one is transformation. So what is transformation? So before transformation we know about the rigid body transformation. So what is rigid body transformation? So here the rigid body transformation have the transformation that do not change the object. So we can not change the object. So we can change only the original object into some other 2D transformation concept, that is translation. So if you translate a rectangle, it is still a rectangle. Scale, if you scale a rectangle, it is still a rectangle. If you rotate a rectangle, it is still a rectangle. So when we apply the translation, scaling, rotation, the object cannot be changed. Whatever the object that we are given to the input, that is rectangle or rectangle, square or square, or circle or circle, that object cannot be changed. Just we can enlarge, or we can rotate some angle, or we can translate from the one position to another position, but the object cannot be changed. Okay, so vertices. So whenever we go to the transformation concept, we can the transformation concept we can represent it by vertices, that is x comma y. Okay, and here in the matrix format, here x comma y input, and it is right in the form of x comma y. Here 21 comma 48. Here the s is considered as a 21 and y is 48. So we can write in the another form of mathematical form, that is rows and the column 21 and 48. So in the matrix and the vector. So after the transformation concept is applied, that new xy coordinate considered as the x dash and y dash, and ABCD or the coordinating system, and the xy is the old coordinate system. So once we can consider this part, then the x dash and y dash can be written as x dash ax plus by and y dash cx plus by. So here in the matrix format it is 1 0 and 0 1. So that corresponding to 3D x dash y dash is z, then a b c d e f g h i x y z. So whenever we consider the x dash, the new coordinate system, it is multiplied by the old coordinate system, that is ax plus by plus ez. For y z, dx plus ey plus bz. For z dash, gx plus hy plus iz. So the diagonal parts are always 1, other than the diagonal parts are 0. Then first, the transformation technique is translation. So what is translation? So translation is nothing but repositioning an object along a straight line path. That is a translation distance from one coordinate location to another coordinate location. So the object cannot be changed. The object is rectangle means rectangle, square means square, circle is circle. But just we can change the position of an object. Okay, that is translation. So here, first the basic x comma y point is in this side. So once we can apply the translation transformation, then the new coordinate x dash comma y dash is considered this. So here after the applicable of translation technique, this position can be repositioned here, this tx comma ty. What is the tx comma ty? So tx comma ty is considered as a distance vector. So the tx corresponding to the x distance and ty corresponding to the y distance. That is, translation is x and translation is y. Then scaling. So scaling is nothing but alter the size of an object. Scales about the fixed point. So alter the size of an object, whether using the scale we can increase or decrease the object. So here consider x comma y, this is the small object that we display. Once after apply the scaling, it can change some enlarge the rectangle side, that is x dash comma y dash. So here scaling given p is equal to x comma y, and x is considered as a scaling factor, that is xx and xy. So first we can take the x as 1.4 and y as 2.2. So after applying the scaling factor, that the scaling factor is given in the problem, here xx is 3 and xy is 3. So when the new coordinate x dash means scaling factor multiply to the old one, and the y dash is considered as a scaling factor corresponding to the y axis and multiply to the old one. Okay, so x dash is xx into xx, y dash is xy into xy. So here x dash. So already we have the scaling factor, both are same, x is equal to 3, xy is equal to 3. So when the 3 is multiplied with 1.4 and the 3 is multiplied with 2.2, here we can have a new coordinate system, that is x dash 4.2 and y dash 6.6. How the 4.2 and 6.6 comes? 3 into 1.4, 4.2, 3 into 2.2, 6.6. So this is the new coordinate system after the scaling transformation is applied. So overall the matrix form, it is written as p dot x dot p. So p dash considered as a new one and x is a scaling factor and p is a old one. Then the rotation. So rotation is nothing but reposition object along a circular path. So rotation requires an angle. Rotation requires an angle, whether it is a 45 degree or 90 degree, or sometime it can be changed into the another 180 degree or 180 degree. So this is rotation. Then homogeneous coordinate system. So in the homogeneous coordinate system, we need to do something to the vertices. By increasing the dimensionality of the problem, we can transform the addition component of translation into multiplication. So this is the homogeneous coordinate. So first we can take the p is equal to x comma y. So once we add the homogeneous coordinate, just homogeneous coordinate system is nothing but to add an extra coordinate system, that is xh. H considered as a homogeneous x, homogeneous y, and the additional homogeneous. So here x is equal to sh by x and y is equal to yh by h. So h is the homogeneous coordinate system. So here 4, 2. Okay, 4, 2, the homogeneous is 1. So whenever you multiply by 4 by 1, it is 4, and 2 by 1, it is 1, and 1 by 1, it is 1. So here example. 3, 7. So like that we can take the homogeneous coordinate system. Then 3D object representation. So how the 3D object can be represented? So a surface can be analytically generated using its function involving the coordinates. Here an object can be represented in terms of its vertices, edges and polygons. Vertices, edges and polygons. These are the three major points when the 3D object can be represented. So curves and surfaces can also be designed using splines by specifying a set of few control points. So the data for polygonal meshes can be represented in two ways. So in the 3D object representation, it can consider in the two ways. First, the method one is vertex list, normal list and face list, that is polygon list. And another method 2 is the vertex list, edge list and the face list, that is polygon list. Here, projection. Here, what is the projection? Projection is nothing but convert the n-dimensional object into n-1 dimensional object. If you have the object in the 3D, then using the projection concept, it can convert it into the 2D, that is n-1, 3-1, 2D. Okay. So here the general definition is transform points in n space to m space, that is one space into another space. In CG, map viewing coordinates to 2D screen coordinate. Here it is a center of projection. So when we project the object from the center of projection, it is the view plane. So we can see the front view of the object. Then parallel projection. So there are two types of projection. The one is perspective and the another one is parallel. So it is the parallel projection. So it is the direction of propagation. It is the direction of projection or direction of propagation. So here it is the object is fixed here and it is the projector and this is in the projected plane. So projections are defined as mapping of 3-dimensional point into a 2-dimensional plane. There are two types. Already I tell there are two types. One is projection, another one is perspective, another one is parallel. First the parallel projection. So parallel projection, where we can use the parallel projection are used by the architect and engineers for creating working drawing of the object. For complete representation requires 2 or more views of an object using different planes. So here, when in the parallel projection, we can use the display picture in its true shape and size. And when projectors are perpendicular to view plane, that is called an orthographic projection. Then the parallel projection is formed by extending parallel lines from each vertex on the object until they intersect the plane of the screen. So the point of intersection is the projection of vertex. So this is perspective projection. So in the perspective projection, it is a COP, that is center of projection. So the center of projection projects the object in the with the help of projector, that the object is placed in the projection plane. Then perspective. Perspective projection are used by artists for drawing 3D dimensional scenes. In perspective projection, lines of project do not remain parallel. The lines converge at a single point called a center of projection. So then the projected images on the screen is obtained by points of intersection of converging lines with the plane of the screen. The image on the screen is seen as the viewer eye were located at the center of projection. Lines of projection would correspond to path traveled by light beam originating from object. So perspective. The two main characteristics of perspective are vanishing point and perspective force shortening. Due to force shortening object and length appears smaller from the center of projection. More we increase the distance from the center of projection. From the center of projection, when we increase the distance, the object will appear in the small. So here some important points that we compare the parallel and projection. The first parallel, the distance of object from the center of projection is finite. Here it is infinite. The distance of the object from the center of projection is infinite. Here the distance of object from the center of projection is finite. Then parallel projection can give the accurate view of object, but in the perspective of projection it cannot give the accurate view of object. Here the lines of parallel projection are parallel. Here the lines of perspective projection are not parallel. There are two types in the parallel projection, that is orthographic and oblique. And here the three types of perspective is 1 point, 2 point, 3 point. That is one dimensional, two dimensional and three dimensional. It is not form realistic view of object, but here in the perspective it forms a realistic view of object, because perspective is nothing but the human eye system. Here orthographic and oblique. So orthographic parallel projection, the projection is perpendicular to the view plane. Oblique, the projections are inclined with respect to the view plane. These are the two major types in the parallel projection, orthographic and oblique. Then here the oblique projection is a method of projection in which an object is depicted using parallel lines to project its outline on a plane. For example, an orthographic projection of a house typically consists of a top view, front view and side view. Then the orthographic projection can be subdivided into three categories, that is isometric, diametric and trigonometric. So here orthographic projection. So this is one object that we are going to see through the view plane in orthographic projection, and when we see the plane, and this is front and above, top and side. Then oblique. So oblique has two types, that is cavalier and cabinet. So in the cavalier project makes 45-degree angle with the projection plane, and in the cabinet it is in the 63.4-degree angle. So here the direction of projection not perpendicular to view plane. So cavalier have 45-degree and the cabinet have a 63.4-degree. Then it is 1 point perspective, one principal face parallel to the projection plane, one vanishing point for Q, and this is 2 point. So consider the image. So when we see the object in the view plane through the front view, it is the 1 point perspective, and it is in the 2D, that is two dimensional, on principal direction parallel to the projection plane and two vanishing points for Q, and this is the 3 dimensional, no principal face parallel to the projection plane, 3 vanishing points for Q. Thank you. So from the overall computer graphics PPT, we can know about what is computer graphics and what are the two types of computer graphics and what are the various fields that the computer graphics can be used, and what are the input devices and what are the output devices, and how the projection can be made in the CG. So these are all the overall topic that we covered under the computer graphics PPT. So thank you for listening. Once again, I thank to our management to have opportunity